Hello everybody and welcome back to another episode of BEDMAS. Hope you're all having a groovy day today. And today we're going to be talking about order of operations. And probably a good chunk of you already know what order of operations are. And if you do, you may be wondering, BEDMAS, why did you wait this long to talk about this? This is a pretty fundamental concept, and it seems weird that we've done a lot of the other stuff we've done before we got to this. And one kind of reason I didn't do that is because I don't want to just talk about how to do order of operations. I want to talk about why they are the way they are. Why did we choose the specific order of operations? So even if you know order of operations, if you don't know why it is the way it is, this video still may be worth your time to watch. And for those of you who don't worry, we're going to go through all the details about how this works.
Motivation and BEDMAS.
So to kind of motivate what order of operations is and what it's for, let's consider an example. 3 times 7 plus 1. So let's say, okay, I start with the multiplication. 3 times 7 is 21, and then I add 1 to it, and I get 22. Great, nothing special. But let's say instead, I was feeling a little silly, and I'm like, okay, I want to do addition first. Why not? So 7 plus 1, that gives me 8. So then I do 3 times 8 and I get 24. Notice something. We do not get the same answer, right? So essentially, the problem arises is that I did these operations in a different order. And sometimes when you do operations in a different order, you're going to get a different answer. So this can be very problematic because imagine, let's say we've got 2 engineers or something, they're building a rocket, and one engineer kind of evaluates multiplication before addition all the time, and he does his measurements and his calculations that way. And the other engineer, he does his addition before multiplication all the time, and he does his measurements and calculations that way. And let's say this guy is working on one rocket engine, this guy's working on another rocket engine. So then we've got 2 rocket engines with very different sets of calculations, and the rocket is going to fail. Maybe it's going to blow up and goodbye SpaceX, who knows. But in any case, we need to basically have something where everyone across the board is evaluating these operations consistently. And that's the goal of order of operations. It gives us an ordering by which we are supposed to do our operations. And the ordering is often written as an acronym called BEDMAS. And BEDMAS stands for brackets, exponents, division, multiplication, addition, and subtraction. Now you may get some variations on this, like PEMDAS, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. But these will give us the same results. And just to clarify some of the differences between these two very common ones, parentheses look like this and brackets look like that. However, we use the terms almost interchangeably for the most part. So brackets can refer to anything that looks like this or like that, and similarly parentheses can refer to either of these forms as long as they're kind of serving the same purpose. This is a little more common to write though than this over here. Next difference you might notice is that the order of division and multiplication are reversed. This isn't going to matter, and I'll explain in just a moment here, but I want to actually dive into just a couple examples of using this system here, and then I'll get into the why it actually is the way it is. But let's just get an idea for what this actually looks like. So let's say I had something like 4 times 8 plus 1 times 3 squared. All right, so we've got several operations here. We've got a couple of multiplications, we have an addition, and we have an exponent, right? That's the 3 to the power of 2. So the question is what's the order in which we evaluate this? Well, the order in which we do it is we just kind of follow our acronym. So there's no brackets or parentheses to worry about, but we can worry about exponents. So exponents is the first thing we're going to evaluate here. So we're going to get 4 times 8 plus 1 times, and then what's 3 squared? That's 9. So that's kind of the first piece of this whole thing that we've evaluated. All right, next up on the list, we're going to have multiplication. And we've got a couple spots that we have to do multiplication in. So we've got 4 times 8, that's 32. and 1 times 9, that is 9. And our addition kind of stays there. We haven't evaluated the addition left. That's way towards the bottom of the list. And now that it's the only operation left, now we can actually evaluate it. So we have 32 plus 9, that is going to be 41. Now, what if instead I did 4 times, and then I put a parentheses here, and whenever you have a right-facing parentheses, you always need a corresponding left one. Otherwise, it doesn't make sense because the whole point of a parentheses is it's going to group things. So the difference between this and this is that according to this order of operations, we evaluate what's in the parentheses first. So what we've actually done is we've said that, okay, I want this multiplication actually to happen last. I want to do this addition of 8 plus all of this first before I do that multiplication. So the really nice thing about brackets and parentheses is that it allows us to do things in whatever order we actually want it to. Yes, we say that the standard is multiplication comes before addition, but sometimes we want to add before we multiply. And we can achieve that by putting parentheses around the thing we want to add, because that is going to have the priority. So if we were to do this example, parentheses comes first, so we're going to evaluate everything inside of here first. So what do we evaluate inside of here first? So let's just refer to the order of operations again. The first thing to evaluate will be the exponent. So 3 squared is 9. So we keep everything else the same. So we still have the brackets, so we have to evaluate everything that's going on inside of here. So we have the addition and the multiplication. Multiplication takes priority, so we do multiplication next. So we have 4 times, and then we have 8 plus 9. All right, now even though we have addition here and multiplication takes precedence, this addition is inside of parentheses, so we have to do this first. So we get 4 times, and then 8 plus 9 is 17. And finally, we can do the multiplication. So we get 4 times 17, that is going to be 68. So notice, we had the exact same operations, multiplication, addition, multiplication, and squaring, the exact same numbers, but just by using these parentheses here, which changed the order in which we evaluate this expression, we got a radically different answer, right? And one thing to note here is that when we do a number times parentheses like this, it's common to, instead of writing multiplication here, just put the number right beside it. This is kind of a notation that we'll see a lot in algebra as well, but it's common to put the number right beside it because there's no ambiguity that we're doing like 48 or anything like that because there's a parentheses in between them, right? So the implication is that by putting it right beside it, this is the same thing as multiplication. So you may sometimes see it written like that. Okay, so now that we have a couple examples under our belt and maybe a bit of an idea for how this order of operations works, let's actually talk about why it is in this order.
Why that order?
So let's start by talking about the first thing in the order of operations, and that's brackets or parentheses. So the whole goal of brackets and parentheses is that it's meant to prioritize certain sections. So if we look up here, for example, when we did 4 times 8 plus 9, we wanted to prioritize the addition. So in order to prioritize the addition, we use brackets and parentheses. But the whole point that brackets and parentheses prioritize things means that we want them to come first. Otherwise, they don't really do a good job at prioritizing things. Right? Imagine if parentheses came in last. Well, then we would basically not be prioritizing anything because we would do everything as normal and then we'd say, oh, we have a pair of parentheses, but everything's calculated at that point, right? So we need them to come first in order to prioritize the expressions that they envelop. So that's why they come first. Next up, we have exponents. Why do exponents come second? Well, what is exponent? Well, an exponent, for example, 5 to the power of 3, that's the same thing as 5 times 5 times 5. Or 7 to the power of 4, that's the same thing as 7 times 7 times 7 times 7, right? Exponents are basically a compact way to write a multiplication statement. And because of this, we want exponents to come before multiplication. Because if inside of an exponent we have a multiplication statement, it kind of makes sense to unpack that first before we do more simple multiplications. Next up, we have multiplication. So we understand the reasoning for why exponents might come before multiplication because they're basically multiplication in and of themselves, just a more compact way of writing it. Well, for a similar reason, we're going to say that multiplication comes before addition. Because if I think of something like 3 times 4, that's literally me taking 4 and adding it to itself 3 times. Or the same thing as taking 3 and adding it to itself 4 times, right? But inside of multiplication, we get essentially a compact addition statement. So because of that, it makes sense to evaluate the multiplication first because that's doing a more complicated addition statement and then afterwards going back and evaluating all the simpler additions. So multiplication is basically compact addition, so it's evaluated before addition. So we can kind of get an idea for why the brackets and parentheses come first, because they prioritize things, why the exponents come before the multiplication, because it's compact multiplication, and why the multiplication comes before the addition, because it's compact addition. But we still haven't really talked about division or subtraction yet. And the reason for that is because in the last several videos, we talked about how basically division and multiplication are the same. And we've also touched on previously why addition and subtraction are the same. So we know that division is basically multiplication because it's the same thing as multiplying by the reciprocal of the number or the multiplicative inverse of the number. All ideas that we've discussed in the last couple of videos. So for example, 3 divided by 4, that's the same thing as doing 3 times the multiplicative inverse of 4, which is the reciprocal, which is a quarter, right? So we can express division statements always as multiplication. And for that reason, we actually get that multiplication and division are interchangeable inside of the BEDMAS ordering, inside of our order of operations. So we have BEDMAS here, and we write D and M, but essentially these are kind of one unit. So they have the same position as each other. So for example, if I did 4 divided by 4 plus 3 times 2, it's not going to matter if I do 4 divided by 4 first, or if I do 3 times 2 first, because 4 divided by 4 is essentially just multiplication by a quarter, right? But we can do 4 divided by 4 is 1, and 3 times 2 is 6, and these are completely separate of each other, and then we can add them together afterwards. And this is also the reason in the other acronym, PEMDAS, why they are done in a different order. Because the order doesn't matter in which the multiplication and division come because they are the same operation. And similarly, it actually doesn't matter the order in which we do addition and subtraction, because we know that addition and subtraction are two sides of the same coin. We know that I could express 3 minus 4 as just being 3 plus negative 4, right? That's basically taking the what's called the additive inverse of 4 here. So even though in both BEDMAS and PEMDAS the addition is written before the subtraction, we could equally have considered an acronym like BEDMSA or PEMDSA, but it just doesn't roll off the tongue as well, right? But the point is that addition and subtraction, they are kind of the same thing, so we can do them in either order we want. For example, if I had 3 plus 5 minus 4, I could do 3 plus 5 first and get 8, and then subtract out the 4 and get 4. Or I could do the 5 minus 4 first and get 1, and then do 3 plus 1 and get the 4. So hopefully this gives you an idea for why the order of operations is specifically in the order it is. Brackets and parentheses because their purpose is to give priority. Exponents before multiplication because it's compact multiplication. Then we have multiplication and division basically in the same tier because we can express division as multiplication. Then we have multiplication before addition because multiplication is compact addition. And then we have addition and subtraction in the same tier because they can be expressed as each other.
Examples.
Now that we understand really why the order of operations are the specific order the way they are, let's get some practice under our belt. So I'm just gonna, for reference, write the acronym up top here. And this is something you can always do. If you're not sure, just write down the acronym. It's fairly easy to remember. And then you can kind of just reference it as you go on. All right, so our first example, we've got 3 times 1 plus 2 squared. All right, so normally we would do the multiplication first. Again, this is multiplication here, just we're not writing the multiplication sign because it's not ambiguous having a number next to a bracket like that. Okay, so, but since we have parentheses here, we are going to actually evaluate this expression first, right? B for brackets or for parentheses. So we evaluate that first. So this becomes 3, and then 1 plus 2 is also 3. So that becomes 3 squared. All right. The next thing we evaluate is the exponent, right? We have an exponent, so we do that before the multiplication. So we get to 3 times 9, right? 3 squared, that's 3 times 3, which is 9. And then lastly, we can evaluate the multiplication, which in this case is going to be 27. All right, not too bad. Let's try another example, but let's use some fractions this time. All right, so in this situation, we have a third plus a fifth times a half minus 1 divided by 2. So just following this order of operations, we can do multiplication or division first. So let's start with this multiplication statement here, just kind of going left to right. So we get a third, and then 1/5 times 2/3, we just multiply the numerators and the denominators, and we get 2/15. And then we can also look at this division statement. But we know 1 divided by 2, that's the same as a half. So it might actually be useful, instead of evaluating this to a decimal, to just have it as a fraction, considering everything else is going to be fractions, right? Okay, so now that we have that, all we need to do now, since it's just a plus and a minus, which we can evaluate kind of at the same time, we just need to make a common denominator. So we got to find a common denominator of 3, 15, and 2, but that should be 30. Multiply these by 10 each, these by 2 each, and these by 15 each. So we end up getting 10 over 30 plus 4 over 30 minus 15 over 30. So we can just add and subtract the numerators. 10 plus 4 is 14, minus 15 gives us -1. So the whole thing evaluates to -1 over 30. So in this situation, we have some exponentiation, we have some addition, subtraction, but we also have division, right? Because it's in a fraction. So if we follow BEDMAS, the first thing we do is the exponent. So we can get that right out of the way. So we have 2 plus 3 over 9 minus 1. Now you might think, okay, division is next, right? That has to come before addition and subtraction. So we should really just be kind of dividing these two out. But the problem is how do I really divide 2 plus 3 divided by 9 minus 1? We don't really know how to divide by a subtraction statement, or we don't know how to divide an addition statement. It's kind of weird to think about. So in some sense, it feels more natural to evaluate the numerator and denominator first before we actually go ahead and divide these. But that seems like it contradicts our order of operations, right? But it doesn't actually. And the reason it doesn't is because when we write something in this notation where we have basically the numerator over the denominator, we kind of think of the numerator as something that's being grouped and the denominator as something that's being grouped. So hidden inside of this, we actually technically have a statement like 2 plus 3 divided by 9 minus 1, where we're grouping everything in the numerator with these parentheses and we're grouping everything in the denominator with these parentheses. So implicitly inside of here, we actually have parentheses. When I write it out explicitly like this, we can see that. But the value of this is that we actually are able then to just evaluate the numerator and the denominator before we even focus on the division. I'm going ahead with that now. 2 plus 3 is 5, and 9 minus 1 is 8. And we can divide this if we want. Or we could actually also just leave it as a fraction, right? We know that fractions are kind of nice for that. So let's just leave our answer as a fraction. But again, the point here is that when you have kind of a fraction written like this, you can kind of treat the numerator as all being inside of parentheses and the denominator as all being inside of parentheses and evaluate them before you consider evaluating the fraction structure, which is division. So this one is a little hairier. It's got more stuff going on. But again, if we just follow our order of operations, we should be good. So we'll start with brackets. Well, right here we have a statement with brackets. And then when we have brackets, we can go inside of the statement and basically relook at our order of operations. So we're just focusing inside of here, and we have to look for brackets yet again. And we do actually have brackets yet again, right? We have this 5 plus 3 statement. So that's going to be the first thing that we evaluate in all of this. So 5 plus 3, that is 8. Okay, perfect. So once again, look at our order of operations. First thing we do is brackets. So we're still looking at this statement here because we still have parentheses. We don't really need the parentheses that were around the 5 plus 3 anymore, since when that evaluated to 8, it's just a single number now, right? So we kind of dropped that parentheses when we've evaluated everything inside of it. But we haven't evaluated everything inside of this larger pair yet, so that's why we still have it here. So we're focusing on this again, and inside of it, what do we do first? Well, we have an exponent, we have a subtraction, and we have a multiplication. So just following BEDMAS, we do the exponent first. So 8 squared, that's 8 times 8, which is 64. So what we end up getting is 64 minus 2 times 20 plus 6 divided by 2. Okay, so we still have the parentheses, but we're getting closer, right? It's getting smaller and smaller. So we can focus on this yet again. So we have 4 times, and we're going to do the multiplication before the subtraction, right? Just following the order of operations, the standard for the way we compute this. So we have 64 minus, and 2 times 20 is 40. All right, and then we have 6 divided by 2. And we're almost done with the parentheses. This should be our last step here. So we have 64 minus 40, that's 24. So what we end up getting is 4 times 24 plus 6 divided by 2. So now we have 3 operations left, a multiplication, an addition, and a division. We can do the multiplication and the division next. And again, it doesn't really matter the order in which we do them. So we get 4 times 24, that should be 96. And 6 divided by 2, that should be 3. So 96 plus 3, that is 99. So our total answer then for this should be 99.
The controversial example.
So let's consider something like 6 divided by 3 times 2. So if order of operations truly doesn't matter the order I do multiplication or division, then both ways should be fine. So if I divide first, I get 6 divided by 3 is 2, and I get 2 times 2, which is 4. Let's try it the other way now. So if I do 3 times 2, that gives me 6. And 6 divided by 6 is 1. Ooh, these are not the same thing, right? So this is an example where it seems like order of operations doesn't really work. And there's a couple ways of mitigating this. The first way is to establish the convention that we always do things from left to right. So if we consider the convention, do things from left to right, then by this convention, this is actually going to be the correct method. And this is usually the convention. People usually say, okay, just do things from left to right. And so this is still a non-ambiguous statement. This would be the incorrect way to evaluate it because you're doing things from right to left. However, because in order of operations, it's emphasized that you can do either multiplication or division, a lot of people will get confused and they won't consider that, okay, if we have division or multiplication, we just kind of evaluate from left to right. And because people get confused a lot of people have started to think that something like this is kind of bad notation, where it's almost intentionally ambiguous. So in order to kind of remove the ambiguity here, there's a couple ways that we can achieve this. The first way would be to just use parentheses, because using parentheses then makes it perfectly clear which one of these pieces we want to evaluate first. So solution 1, use parentheses, right? That makes it crystal clear what you want to have evaluated first. So we're going to have 6 divided by 3 times 2. That emphasizes we want to evaluate the division first. Or if we did 6 divided by 3 times 2, that emphasizes that we wanted to evaluate the multiplication statement first and then divide afterwards. Another method, and this is pretty much the same thing, except we're more implicitly using parentheses, and that would be to use fraction bars. Because we know fraction bars are the same thing as division, right? So in this situation, we would write it as basically 6 over 3 times 2, and then it becomes clear, right? We know that we can do 6/3, and we can simplify that down to 2 first, and then multiply this by 2. And then in the other situation, we're doing 6 divided by all of this, so we would actually write that as 6 over 3 times 2, like that. And again, these are the same thing where we evaluate everything in the numerators and everything in the denominators first, as though those basically have kind of a hidden pair of parentheses in them before we do the complete division there. So this is an example that kind of went famous on the internet, where a lot of people were arguing which is the way to do it. Do we do the division first or the multiplication first? If we follow the convention of doing things from left to right, we do the division first. But since so many people disagree on this, it's just better to use parentheses or fraction bars to eliminate any sort of source of controversy or disagreement. Because again, the whole point of order of operations is to have an established way of evaluating an expression that everyone agrees upon. And if there's an insane amount of people disagreeing on this topic, maybe it's just better to have something where everyone can agree on it and it still works consistently.
Concluding thoughts.
Okay, so I hope you found this video useful. I hope you're getting a good idea for what order of operations is and what the point of it is and why we've chosen the order we have. And don't you worry if you're a little bit uncomfortable still, because I've got a full practice video coming your way. So until then, you have a good one, you stay absolutely groovy, and I will see you, and I'm going to see you, in that next BEDMAS video.